Dear student, in today's lecture we start problem from chapter 4 thermodynamics. We start with the MCQ. Choose the correct option. First MCQ. A gas in a closed container is heated with 10 joule of energy, causing the lid of the container to rise 2 meter with 3 Newton of force. What is total change in energy of system? So total change in energy we can find out by first law of thermodynamics. So using first law of thermodynamics, change in internal energy is equal to Q minus W. Q is the heat and W is the work done. So here 10 joule is heat. So Q is given. Only W we have to find out. So work done is the force into displacement. So this force is a 3 Newton, displacement is 2 meter. So 3 into 2, 6 joule is the work. So change in internal energy is equal to Q minus W. So 10 minus 6 and it is 4. So answer for this question is 4 joule. Next question. Which of the following is an example of first law of thermodynamics? First law of thermodynamics is related to the conservation of energy. Energy is conserved. So if you observe all the options, then so here option 4 means option D here. After falling down the hill, a ball's kinetic energy plus heat energy equal to the initial potential energy. When ball is at height, that time ball having a potential energy. When it starts falling down, this potential energy is converted into the kinetic energy and some part is converted into the heat energy also. So kinetic plus heat is equal to the initial potential energy. So this fourth one is uh, perfectly related to conservation of energy. So this is example of conservation of energy. So answer for this question 2 is option D. So question number 3, efficiency of a Carnot engine is large when. So efficiency formula we must know. Efficiency is given by TH minus TC divided by TH. Now here the efficiency we get large when TH is large. If you see this formula, if TH we substitute larger, then obviously this eta means efficiency is larger. Our second one is TC is low, this TC is low, then also we get efficiency larger. Or the third one, TH minus TC is large, then also efficiency is large. So answer for this question is coming A, B, and C. So it means that something is wrong in this equation, in this question. Maybe here instead of large, it may be a small. Then we get a particular answer. But here, if it is a large, then we get A, B, and C as the answer option. Now let me modify this equation. Efficiency of Carnot engine is low when. So efficiency formula is TH minus TC divided by TH. And it is low only when this TH minus TC is large. Only one option is coming when we modify this equation, modify this question. The next question is second law of thermodynamics deals with transfer of. Second law of thermodynamics is, let I tell you, the heat supplied is utilized to increase the internal energy and to do the work. Hence it is related to conservation of energy. So it is related to the heat. But you know that heat is a one type of energy. So energy is also not the means appropriate answer. But here the more appropriate is the heat for this. So heat is the right answer for second law of thermodynamics because we are dealing with the heat. But heat is a one type of energy is also. Next one is the question number 5 from exercise. A system releases 125 kilojoule of heat while 104 kilojoule of work is done on system. Calculate change in internal energy. Now here let me write the given here. So here Q is 125, the heat energy. So this heat energy is released. So this heat is lost by the system. So minus 125. So work is done on the system. So work done is negative. When work done by system, that time positive. So it is work done on system. So work is minus 104 kilojoule. Now we use first law of thermodynamics. Delta U is the change in internal energy is equal to Q minus W. So Q is minus 125 kilojoule minus this work done is minus 104 kilojoule. So here after doing this calculation, minus 125 plus 104 is coming minus 21 kilojoule is the change in internal energy. So this minus sign indicate that the internal energy decreases. Now question number 8. An ideal gas is taken through an isothermal process. If it does 2000 joule of work on its environment, how much heat is added to it? Here let me write down the given. Here work done is 2000 joule and the process is isothermal process. So when we are heating any gas under this isothermal process, heat supplied is used to do the work. It is not used to do increase the internal energy. So change in internal energy is zero. So we use first law of thermodynamics. Q is equal to delta U plus W. So delta U is zero because change in internal energy is zero. So Q is equal to W is the equation. Now let me substitute W here. W is 2000 joule. So we get Q is equal to 2000 joule. Now question number 9. An ideal gas is adiabatically compressed. Now here very important here. It is compressed adiabatically. Adiabatically compressed so that its final temperature is twice the initial temperature. What is the ratio of final pressure to its initial pressure? Now let's see the solution of this problem here. The given final temperature is twice the initial temperature and it's a monoatomic gas molecule. For monoatomic gas molecule, this gamma is equal to 5 by 3. So this gamma is ratio of specific heat, Cp by Cv. Cp by Cv is 5 by 3. Now here, the gas is heated adiabatically. When it is heated adiabatically, then we can write PV raised to gamma is constant. So here, we can write Pi Vi raised to gamma is equal to Pf Vf raised to gamma. Now, PV is equal to nRT. By using that, V is equal to nRT by P. Let me substitute the value of V here. So, Vi is equal to nRT divided by Ti divided by Pi. Ti and Pi initial temperature and final initial temperature and pressure. Tf and Pf final temperature and pressure. Let me substitute and see what we get. So here we get, after substituting in this equation, we get Pi in a bracket nRT divided nRTI divided by Pi raised to gamma. Pf is equal to Pf in a bracket nRTF divided by Pf. Now here the common term we can cancel here, nR get cancel. So we get the term Pi divided by Pi raised to gamma. Now you know that Pi divided by Pi raised to gamma. It is coming Pi raised to 1 minus gamma by law of indices. So here it is written Pi raised to 1 minus gamma. And this Ti raised to gamma as it is equal to Pf raised to 1 minus gamma into Tf raised to gamma. So this is the formula. Now here, let me write here Tf divided by Ti. Tf divided by Ti means this divided by this raised to gamma is equal to Pi divided by Pf raised to 1 minus gamma. Now here we substitute the values. This Tf divided by Tf is 2 into Ti here in this one. So we get 2 raised to gamma. Gamma is 5 by 3. So 2 raised to 5 by 3 is equal to Pf divided by Pi raised to gamma is 5 by 3 minus 1. So 5 by 3 minus 1 is 2 by 3. And 2 raised to 5 by 3 is equal to Pf divided by Pi raised to 2 by 3. And by you solving this, we have to find out ratio of final pressure to initial pressure. Means we have to find out PF divided by PI. Now we can find out this 2 raised to 5 by 3. And or otherwise we can do one thing here. We can take the log of both sides. Take the log, we get 5 by 3 log of 2 is equal to 2 by 3 log of PF divided by PI. Now here is 3 and 3 get cancelled. This 5 by 2 is 2.5. So 2.5 log 2 is uh, log 2 is 0.3010. ठीक है, this we can write 2.5 into 0.3010. So you can see here. So this 2 is shifted here, this side. So it is 5 by 2. So 2.5 is equal to log of PF divided by PI. Now this multiplication is coming 0.7525 is equal to log of PF by PI. We have to find out this. So we have to cancel the log. So take the anti-log. So PF divided by PI is anti-log of this value. And anti-log of this is coming 5.656. So this is a ratio of final pressure to initial pressure. And this is the answer of this question. The ratio of final pressure to initial pressure is 5.656. Now question number 10 from exercise. A hypothetical thermodynamic cycle is shown in figure. Calculate work done in 25 cycles. So here let I tell you the hint here. Work done in one cycle. So is equal to area under curve. Now how we find out area under curve? So this is a elliptical path. This is not a spherical. So we can say that this is the A, this is B. Okay. So pi, you know that area of circle is pi r square. So such kind of, this is a elliptical path, elliptical. So area is pi A multiplied by B is the formula. Pi. Now we can find out in term of, this is a P. So this is what P2 and this is what P1, and P2 minus P1, half of that we have to write. So P2 minus P1 divided by 2 multiplied by, this is V2, this is V1. So here V2 minus V1 is 6 minus 2 means 4, 4 by 2. So here V2 minus V1 divided by 2. So here we can write pi upon 4 into P2 minus P1 into V2 minus V1. It is a formula for work done for one cycle. And if you multiplied it by 25, then we get work done for 25 cycle. I hope everyone understood this formula. Now let's start here. Work done in one cycle is area enclosed by this PV curve. So area enclosed is 4 by pi by 4 into P2 minus P1 into V2 minus V1. I hope everyone understood how we get this work done formula. Now let me substitute here pi by 4 as it is. P2 is what? 11. You can see here this is a 11. Then P1 is what? 1. Okay. And this is in 10 raised to 5. Here it is commonly written. So into 10 raised to 5 outside. Then V2 is 6. V1 is 2. So 6 minus 2. Into everything is 10 raised to minus 3. So into 10 raised to minus 3. Now we have to solve to get work done. Now let me solve here. Pi by 4 into 10 raised to this 10 and 10 raised to 5, 10 raised to 6. 6 minus 2 is 4. 4 into 10 raised to minus 3. So here this 4 and 4 get cancelled. So we get pi into 10 raised to 3 is the answer. So here you can see here pi into 10 raised to 3. So pi is 3.14 into 10 raised to 3 joule. This is the work done in one cycle. So work done in 25 cycle is 25 into this. So we get answer 7.85 into 10 raised to 4 joule. And this is the work done in 25 cycle. Now question number 12. A system is taken into its final state from initial state in hypothetical path as shown in figure. Calculate work done in each case. So you can see a diagram here. A, B, C, D is the path. And we have to find out work done. So here, PA, pressure at A, you can see here, this is AB. Pressure at AB is 6 into 10 raised to 5 because everything is in 10 raised to 5. Pressure at C and D is 2 into 10 raised to 5 here, you can see. Volume at A and D, it is 2L. And volume at B and C, it is 6L. And 1L is equal to 10 raised to minus 3. L means liter. It is equal to 10 raised to minus 3 meter cube. Now we have to find out work done in each case. So let me find out work done from A to B. So A to B, you can see here the pressure is constant. At A and at B, pressure is same. So it is called as isobaric process. So work done is given by formula P into delta V. So you know that work is given by formula P into delta V. Or you can write like this way, P into delta V. So here change in volume we have to take into the consideration. So pressure we substitute 6 into 10 raised to 5. Change in volume is 6 minus 2 into 10 raised to minus 3. So after solving this, we get 2.4 into 10 raised to 3 joule as a work done for a path A to B. Now next path is we have to find out work done for path B to C. So work done, I told you P into delta V is the formula. So delta V is the change in volume. So if the change in volume is 0, here B to C, change in volume. At B volume is 6, at C volume is 6 liter. So change in volume is 0. P into 0 is 0. So as well as A to D also no change in the volume. So work done is coming 0. So then we have to find out C to D that we find out. So for the next part, you can see here. So work done B to C, it is 0 because volume is constant. Now work done along the path C to D. Again, it is isobaric process because pressure is constant. So same formula. So pressure is 2 into 10 raised to 5. VD, volume at D is 2, volume at C is 6, and into 10 raised to minus 3 meter cube. After solving this, we get minus 8 into 10 raised to 2 joule is the work done. Now work done for the path D to A. It is again 0 because volume is constant.